Well, welcome to Unit 9. It's Mr. O, and I'm going to lead you through this unit. This unit will comprise of square roots that we're going to start with here. We're going to go into the quadratics that you just did in the last unit, and we're going to learn how to solve them algebraically using several different methods. And we will wrap up the unit using cubic roots. So hang in there, and let's roll. All right, so if we start this off here, square roots basically are going to be the opposite of squaring something. So just like adding and subtracting are opposites, multiplying and dividing are opposites, so will be square roots. It's the opposite of squaring. So if you take a look at exercise 1A, and you take a look at 25, square root of 25, that's the same thing if I break up the 25 as 5 times 5. When I do that, I get a pair of buddies. And anytime you get a pair of the same thing under the radical, you can pull it out. So the square root of 25 is equal to 5. Okay? By the same mean, if I take d and I do the square root of 0, what times itself equals 0? So you get 0 times 0. So if I take out that pair of buddies there, you're going to get equal to 0. And if I take a look at, let's see here, e, I take the square root of 140 and say, well, I can't do a fraction. Yes, you can. You take the square root of the top, which is the square root of 1, over the square root of 4. Well, what is the square root of 1? What number times itself is equal to 1? Well, of course, it's 1 times 1. If one number times itself is equal to 4, that's 2. So when I'm done, I get 1/2 as my answer here. Okay? That's how we take square roots. I want you to pause the video right now and do B, C, and F, and then check them in a moment. So please pause. Okay, you should pause the video here and just check your answers. All right, now, if you take a look down here, it basically says, generally agreed upon that always we get positive square roots. Well, that's not necessarily true because we can deal with also negatives, and that's what we're going to look at on the next page. So here we go off to exercise 2. All right, in exercise 2, it does talk about the positive values. Well, when I take the square root of 4, okay, you actually take the square root of 4. There's two ways to get that 4 here, okay? You can do 2 times 2, okay, and that gives you a pair of 2's, which is 2. But also to get a 4, well, when I multiply it's a 4, and also to get a 4, I can do a negative 2 times a negative 2. That will also give me 4. So there's actually two answers. And you can either display them separately like that, where I got 2 and negative 2, or in B, if I take the square root of 36, I get actually plus or minus 6. So 6 times 6, or negative 6 times negative 6. And fractions, once again, don't be afraid of them. Take the square root of 1/16, you get plus or minus. Square root of 1 is 1, and the square root of 16 here is 4. So you get plus or minus a quarter. Exercise 3, you should be getting used to all the way along this year. You got an input case here. What's f of 46? They want to plug it in, find the output, remember substitution, put it in right there, so it's real easy. You're taking the square root of 46 plus 3. Well, what is 46 plus 3? It's 49, and what number times itself is 49? It is 7, okay? So there's our answer, choice 4. So don't be afraid of those. Moving on to exercise 4. All right, exercise 4, they're kind of come across the property we're going to learn about here with square roots. So if I take part A, I know that the square root here of 4 is equal to 2. And I know that the square root of 9 is equal to 3. So 2 times 3 is going to equal 6. And if I do it individually here on this one, and it's part C, the square root of 4 is 2, the square root of 25 is 5, and 2 times 5 is 10. Now I want you to do the numbers under the radical here next. First, so you'll start off with the square root of 36, and what is that equal to? So pause the video, and I want you to finish B and D, and then check your answers on the next page. Okay, your answers here you should have come up with, if you take a look here, 6, like we talked about, square root of 36 is 6. When you do 4 times 25, you get 100. Square root of 100, of course, is 10 times 10, so it's 10. Those are your answers. So what does that give us? Well, we got two things going on here. Individually, we can take the square roots, multiply the answers, and get an answer. And we could also combine the two under the radical and get an answer. Well, that's going to lead us to our next properties here. I'm going to show you on that. So hang in there. Okay, so if you take a look up here, here you go. Square root of A times the square root of B can be put together under one radical. You can do that with anything. They don't have to be like terms to put them under together as a radical. Just like polynomials and that, you do monomials, you can multiply anything you want. Adding, subtracting, you have to have like. Radicals are going to work the same way because they're actually the inverse operations of all the other things. Likewise, if you have two together under two numbers under a radical, you can split them apart into two separate radicals. So that's what we're going to deal with here. So we move on to exercise 5. Take a look at exercise 5. I can't do anything with the square root of 2, can I? Square root of 8, I can bust up. So square root of 2 is 2. I can bust up 8 into what two numbers? Well, we can do 4 and 2. Okay. If you want to bust them up further, I can keep the 2 under radical. I can bust the 4 up into 2 times 2, according to this rule up here. Okay. And I still have that other radical too. Well, here's where I get those pair of buddies. Here's a pair of buddies. That yields a 2. And here's another pair of buddies. So that yields another 2. Well, what's 2 times 2? It's equal to 4. There's I get my answer. The same way you could have just done right away, square root of, well, what is 2 times 8? It's 16. What's the square root of 16? 4. So either way, you could have solved the problems there on that one. If I look at the next one, yeah, I like the shortcut. If I do 3 times 12, I get 36. What's the square root of 36? Well, it's going to be 6 here, okay? And I do the last one, square root of 20 times 5. That's square root of 100, which we know the answer is 10. But if I do it the longer way, I could break up 20 into 4 times 5. And then I get another radical, 5, right after it. Well, you know the square root of 4 is 2. You know a pair of buddies here, so the 5 comes out. What's 2 times 5? The answer of 10. So a lot of ways you guys can do this. It's up to you. Square roots, we have fun either way. Both rules work fine. All right, now in exercise 6, we're going to start looking at things that are not necessarily perfect squares. But to do that, let's first start at part A. It says list out the perfect squares. Well, we know the first 10. What is 1 times 1? That's a 1. The next one, 2 times 2 is 4. 3 times 3 is 9. 16. 5 times 5 is 25. 36. 7 times 7 is 49. 64. 81. And 100, and so on, and you can keep going. Those are the perfect squares, okay? Now, they tell you in B, it says consider the square root of 18. Which of these perfect squares is a factor of 18? Well, which of these numbers goes into 18? Well, obviously, it cannot be bigger than 18, so forget these. So when we're looking at these first ones, which of these numbers go into 18? Well, yes, 1 does, but what's bigger? Does 4 go in? Does 9? Does 16? Yes, 9 does. So when we do something like that, what we can do is say, hey, 18 can be busted up. If I take 18, it's the square root of 9 times the square root of 2. I can rewrite it that way. Then they actually want us to simplify it over here in part C. Well, what is the square root of 9 here? Well, square root of 9, you know by now, is 3 because it's 3 times 3. Can I bust up the square root of 2? No. So when I'm done, I actually have something called simplest radical form here. I get a number out in front of coefficient, and then I get a radical. It's kind of like saying 3 times x. That's the coefficient out in front, and then the variable. Your variable is now a radical. So you're going to see us leaving answers in what's called simplest radical form here, and it looks like that, and that's breaking these up. All right, so in exercise 7, we're going to do just like we just did. Let's break up square root of 8 first of all. Well, what perfect square goes into 8? Does 1? Yes. Does 4 is the next one? Yes. Then 9. 9's too big, so we're going to go with the biggest one, which is 4. So I'm going to get the square root of 4, and what times 4 gives me 8? 2. And now you bust it up. What is the square root of 4? That thing turns out to be 2, and I have a radical 2 left over that I cannot do anything with. If I take a look at C, we're going to take one way. You can bust them into smaller ones, but let the perfect squares go in it. 1 does, 4 does, 9 does not, okay, because you got 9 times 5 is 45. Then 16 does. You might have to use your calculator and take 48 and see if it divides by 16. 25, and then after that, you're getting too big because it's over twice. So you don't have to worry about it. It's usually halfway. So this one is actually the square root of 16 times square root of 3. That's the biggest one. Fastest way to get there. Well, what is the square root of 16? It is 4. And radical 3 I can't do anything with. Now this one in D might make you panic a little bit. You got a negative sign. Big deal. Leave it out in front. Let's break up 75. Well, what's the biggest perfect square that you can think of goes in there? And if you say 25, you're right. 25 times 3. What is the square root of 25? It's a 5. Radical 3 I can't do anything with, and guess what? That negative sign out in front is really an unwritten -1 times this. Well, that just means the negative sign's still there. All right, I want you to pause the video, and I want you to do B, E, and F. Give those 3 a try, and then we'll check your answers on the next screen. All right, so here are your answers. If you take a look here at this one, actually I've got the answer there, but I'm going to talk about it. Square root of 45, the biggest one I've got going into is 9, so you get 9 times 5. Square root of 9, of course, is 3. Radical 5 is not coming out. 72 is a tricky one. You might want to stop short, but it turns out to be 36 times 2. 36 is the biggest perfect square that goes into it. So that's square root of 36 is 6 times radical 2. And then this one here is a little more obvious. You should recognize 5 times 100. Square root of 100 is 10. The 5's not coming out at all, and the negative sign stayed out in front, like I said. Okay. Now, I've got one extra thing I want to go over with, which is not on your sheet, just to help us out a little bit. So at the very bottom of your page there, below this 7F and that, try to make room for the next page. So let's going to stay right where you are, but I want you to write this example in. All right, so this one, like I said, is not, it's an additional example, and put it below 7F there. So please write this right here, okay? I got 3 square root of 16 minus 2 and all over radical 5. So pause the video and write that one down. All right, now that you've written it down, let's take a look at this here. I can take the 3. What's radical 16? What's the square root of 16? Well, it's 4. So basically I got 3 times 4 minus 2 all over 5. I just want to do a little example of some adding, subtracting with these radicals, okay? And so 3 times 4 is 12 minus 2, all divided by 5. Bring that down here. What's 12 minus 2? It's 10 divided by 5 is equal to 2. That's our final answer. Sorry there. Okay. I just wanted to see one of these because we've got some stuff in the worksheets we're going to cover, and they didn't quite cover this in the notes too well. So I just wanted you to see one of these. Do not be afraid, though, if you get adding, subtracting. Break things down, do what you know with it, and we're going to run from there, okay? All right, write a nice WSQ, and be ready for class tomorrow.